Good morning everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronic and Communication Engineering. In this video lecture series, I'm going to explain about the pulse communication. There are various types of pulse communication. Pulse communication is nothing but it refers to the category of modulation techniques where information is transmitted using a series of pulses which can vary in different properties such as amplitude, width, position or code. As I said, there are various types of pulse communication. The first one is pulse amplitude modulation, the next one is pulse width modulation, and the third one is pulse position modulation. These techniques are fundamental in digital communication systems and are essential for converting the analog signal into the digital signal. In this particular video, I am going to explain about what is meant by pulse amplitude modulation. Pulse amplitude modulation is nothing but a key modulation technique which is used in digital communication for transmitting analog data and is one of the most widely used types of analog to digital conversion. The process is very simple where the amplitude of the sequence of pulse changes with the instantaneous amplitude of the analog message signal. The analog signal that is to be modulated is sampled by a sequence of pulses that are amplitude modulated on the carrier to produce the amplitude modulated pulses. This is nothing but the signal transmission of a pulse amplitude modulation. The first one is message signal, the next one is carrier signal, and final one is modulated carrier signal where the message and the carrier signal is being modulated and the final output is here where the pulse varies in accordance with the amplitude. Where in we can able to differentiate over there in the third signal where the pulse is first at the initial the pulse is reduced while the message is transmitting over the range the pulse increases as shown in the diagram. This is the block diagram of a pulse amplitude modulation, low pass filter, multiplexer, modulator and a pulse generator. It's a modulation technique where a series of amplitude, that is series of pulses is varied according to the amplitude of the analog signal which is being transmitted. The various functions of pulse amplitude modulation are sampling, quantization and the modulation. In sampling, the periodically analog signals are sampled at the initial, that is called as a sampling intervals, and an aliasing of these has no chance if we put a condition for the sampling rate. Nyquist's theorem states that the sampling frequency must be at least twice the highest frequency component of the signal. The next one is quantization. Each sample is provided with quantized amplitude. The third one is modulation. Here the amplitude of the generated pulses constitutes the sample quantization level where only single pulses are produced if every sample level is integer. Then the pulse does not change its width but its amplitude can adapt any of the quantified sample values. Then the next one is transmission through the medium of transmission, reception and the reconstruction. Then the pass through filtering, where in the transmission through the medium of transmission where the wireless or wired pathway depending on the framework of the purpose that lies behind the transmission. In reception, the amplitude modulation which then undergoes a process of demodulation. In reconstruction, the summation of different orders of the magnitudes is being used for the interpolation, and pass through filtering will be having various passes, that is high pass filtering, low pass filtering likewise will be having the various frequency component. This is the demodulation of the PAM signal, where here extracting the original data from the modulating signal is called the demodulation process. We'll be using here a reconstruction filter. Here the distortion caused by the use of PAM by transmitting an analog information biasing signal is referred to as the aperture effect, and it is being given to the equalizer. The applications of PAM are the digital data is being sent and it is being used for electrocardiography. Then pulse width modulation. Here techniques are used in PAM based industrial automation systems to control the motor speed and the position. We'll be going with an activity where analog information is converted into the digital data using these types of then the disadvantages are the PAM is inexpensive, then it uses simple signal processing and it is very simple and it transmits analog data over the digital data. Assessment here, what do you mean by the term PAM and when compared with the other pulse modulations, and also what are the different types of pulse communication we have seen. Thank you.